Hi, Landon. So let's review what we've learned this far. We've just started talking about fractions, and we've learned that fractions are less than one whole. Fractions fall in between 0 and 1 on our number line. We know that the top number in a fraction is the numerator. It's the parts that are being used, whether it's the parts that are blue or the parts that are white or the parts that are shaded or not shaded. Whatever parts are being used or talked about, that's the numerator. To me, the denominator is the easiest number to find because you simply count the total number of parts. So the denominator, it is the bottom number in a fraction, and it's just the total number of parts that are there. So today, hopefully you watched that other video because we're going to talk about equivalent fractions today. And on that other video, let me pull this up really quickly. They talked about fraction tiles. So with what we know about fractions, we know that they are less than one whole. Now, your denominator is going to tell you how many pieces that whole has been split into. Like this is 1/2. So I have one piece here, one piece here. This is 1/3. So that means it's been split into 3 total pieces. And each of these thirds are worth 1/3. 1/3 plus 1/3 plus 1/3. Remember, anytime I have that same numerator over that same denominator, it's equal to one whole because that is the same as my one whole right there. So we're going to take a look a little bit deeper about with fractions today. Let me get all this off of here. Now I do want you to notice what happens as my denominator gets bigger. So I have 2, 3, 4. So if you look at each set of fraction tiles, as that denominator gets bigger, what's happening to the size of my pieces? Yes, the size of my pieces are getting smaller. So we have this saying in here in 4th grade math: the larger the denominator, the smaller the piece, or the smaller the part. So as my denominator gets bigger, my piece is actually getting smaller. If you'll take a look at this 1/5 as opposed to this 1/6, or my 1/2 as opposed to this 1/12 down here. So the more pieces that I cut my whole into, the bigger that denominator gets, the smaller my pieces are. Consider a pizza. If I just cut it into fourths, that's a pretty big piece of pizza, right? But if I take that pizza and say, okay, now I want to give it 8 total pieces, which my pieces are not even because my lines are terrible. Now I want to give it 8 total pieces. Look at what happened to the size of one piece for my 4th and the size for one piece for my 8th. Even though 4th is a smaller number, I only have 4 total pieces, so my pieces are bigger. Even though my denominator here, 8, is a larger number, I have more pieces, so therefore my pieces are getting smaller. All right, so let's take a look at equivalent fractions. So we're going to talk about equivalent fractions today. Before I move to the next screen, I do want to type this word on here, equivalent. Now, whenever you see equivalent, you should think of the word, which we've talked about this before in class, equal. Equivalent does mean equal. Equivalent fractions are fractions that name the same amount. So the fractions may look different, but they're going to name the same amount. Let me give you an example of that. Let's erase all of this off of here. So I give the example today of a candy bar. All right, so I'm going to continue erasing this, but I use the example of a candy bar today. So I have one whole candy bar. So let's say that I give you, I take my one whole candy bar. Let's say that I give you half of that candy bar. But I give Bradley 2/4, which, sorry, it's terrible. I'm trying to outline it, but I'm not very good at that. I give Bradley 2/4. So I just gave you 1/2. I just gave Bradley 2/4. Now, should either of you be upset that you got one piece, but Bradley got two? That's what we're talking about today. How my fractions look different. Those are two completely different fractions, but really they name the same amount, because if you look right here, my 1/2 and my 2/4 are exactly the same size. So even though, that's terrible. So even though they look different, these fractions name the same amount. And we can use, now you're not always going to have a number line. You're not always going to have your fraction tiles, but we can use math to help us determine equivalent fractions. I can put your 1/2 and Bradley's 2/4 and see if they're equal. And how we do that is we take a look at the numerators and the denominators, and we look at the relationship between the two. So thinking multiplication wise, how could 1 turn into 2? I could say 1 times 2. Now, here's where we have my golden rule in math. So the golden rule in life is do unto others as you would have them do to you. The golden rule with fractions is kind of similar. If I do it to the numerator, I've got to do it to the denominator. Or if I do it to the denominator, I have to do it to the numerator. So with that golden rule said, if I multiply by 2 on the top, I have to multiply by 2 on the bottom. And if 1 times 2 is 2, and it works out on the bottom, 2 times 2 is 4, yep, these two are equivalent fractions. So let's take a look at that. And just keep in mind, equivalent fractions are fractions that name the same amount. So looking at these examples, let me zoom in just a little bit. Let's look down here at number 1. That's really close, but I think I'm going to need it that way. So they do give us models here, and if you remember, that is 1 out of 2 total parts. That's 1/2. My denominator is 6. Now it really tells you the answer, but I want you to try to not count the number of pieces. And let's do it this way. I can't use my numerators here because I'm missing a numerator. So I can't use them. So let's use the denominators. I have 2 and 6. How can 2 change to 6? 2 times 3. Well, if I multiply 2 times 3 on the bottom, guess what? I've got to multiply times 3 on the top. So my equivalent fraction here for 1/2 is going to be 3/6. 1 times 3 is 3. 2 times 3 is 3. 2 times 3 is 6. So I followed that golden rule. So now let's look right here. I can't use my numerators because 1's missing. Let's generate a fraction, an equivalent fraction for 2/10, using 5 as my denominator. So how can 5 change to 10? 5 times 2 gives me 10. Well, if I do times 2 on the bottom, I got to do times 2 on the top. All right, what times 2 gives me 2? Well, the only number that works here is 1/5. So 1/5 is the same amount as 2/10. So if I gave Tessie 1/5 of the candy bucket and I gave you 2/10 of the candy bucket, then it would be the same. They would be broken up. These parts would be smaller, but you'd have more of them, so it would equal out. All right, last example on this one. How can, I can't use my numerators because I don't have both of them. How can 4 change to 12? 4 times 3. So 1 times 3 is 3. So 1/4 is equivalent to 3/12. So let's look at the next side. Let's look at some more examples up here. Now, if you understand it, you don't have to sit here and read through all of, or watch all of this. But I do want to give you some more examples just to make sure you understand it. All right. So let's take a look. 1/2 equals to blank fourths. So let's take, they don't give me both numerators. Let's take my denominators. 2 times what gives me 4? 2 times 2. So 1 times 2 is 2. All right, can't use my numerators here. Use my denominators. 3 times 2 gives me 6. So what times 2 gives me 4? That'd be 2. So here on the first one, I have 1/2 is equivalent to 2/4. On this one, I have 2/3 is equivalent to 4/6. All right, let's look at number 3. How did 3 change to 9? 3 times 3. So if I do times 3 on the bottom, I have to do times 3 on the top. So 2/3 is equivalent to 6/9. If you wanted to pause it here to see if you understood the last 3 that we're going to do together, you could. So let's take a look. How can 2 change to 4? 2 times 2. So 5 times 2 is 10. And how I know which one to look at is which one that they give me both of either the numerators or denominators. Like here, I was missing a numerator, so I had to look at the bottom. But here, I'm missing one on the bottom. I'm missing a denominator, so I need to look at the top. So if 3 times 2 is 6, what times 2 gives me 8? So 3/4 and 6/8 are equivalent. How can 1 change to 2? 1 times 2, so 3 times 2 is 6. Now you can also make equivalent fractions like they're doing down here. On this one, they gave you the total number of pieces they wanted to be on the bottom. So this one has 1, 2, 3, 4. Oh, sorry. 1, 2, 3, 1, 2, 3, 4. That one has 12. So 3 times 4 gives me 12. 2 times 4 gives me the 8 that are filled in. Now, if they did not give me this picture up here, you could technically generate a fraction, so ignoring this picture. If you have to make an equivalent fraction, the only thing you have to worry about is following the golden rule. So if I make that equivalent fraction, sorry, I didn't want you to look at that for this one. If I can make any equivalent fraction to 1/3, I just have to multiply the top and the bottom by the same number. So I could say 1 times 2 is 2, 3 times 2 is 6. Or I could say 1 times 3 is 3, 3 times 3 is 9. Or 1 times 4 is 4, 3 times 4 is 12. You could keep going. As long as you multiply that numerator and denominator by the same number, they will all be equivalent. All right. This is just breaking down that process. This takes away those models that you were using. I really don't like for you to have to rewrite the whole thing. So I don't really like to use this as a helper in class. But let's just take a look at it just so you have a few more examples. What I like to do is I like to kind of ignore this middle part right here. That way you have less to write. And so now all you have to do is ask yourself, well, how did, I'm missing a numerator, how did 2 change to 6? 2 times 3. So 1 times 3 is 3. So this page is basically doing the same thing. It just gives you a little bit more work here in the middle, and I don't like that. I like the short and sweet way where you just write out beside the numerator and denominator what you multiply by. So I hope these 2 videos have helped. If you have any questions, as always, just comment or post it anywhere in Google Classroom. It'll give me an update or notification, or, get mom to message. But I really want you to show mom and dad just how good you've been doing in class. So show out for me and take your time. This doesn't all have to be finished in a second, but work hard because you just took home some really great math grades. And I want it to be the same way whenever you come back. I want us to keep doing good math grades, okay? Because I know you can. But if you don't do any of this work, and if you don't listen to mom and dad helping you through it, then our grades aren't going to be there where they were at. Okay, bud? Again, let me know if you need anything. I miss you. I hate you're not here, but we're going to make the best of it. Bye, dude.